Okay, here we have a short video on talking about how we can find the angle between two given vectors. By definition, we can find the angle between a vector u and a vector v by using the cosine of theta is equal to the dot product of u and v, or the two given vectors, divided by the magnitude of u times the magnitude of v. So there's a visual picture down there that if you have two vectors, u and v, going in different directions, that we can again use cosine to figure out what that angle is that separates the two vectors. So let's take a look at an example. So here we have a picture of two vectors, and we also have the component forms of the vectors. U is 4, 3, and v is 3, 5. We're going to work backwards to figure out what that angle theta is. Well, let's do each piece of the formula that we had on the previous page. So first, I'm going to give u as red and v as blue, and I'm going to go in and figure out what is that dot product between u and v. Well, we're going to multiply the corresponding component forms. So we want to take 4 times 3, the first component of u times the first component of v, and we're going to add to that the first component, or the second component of u, multiplied by the second component of v, which will give us 12 plus 15. So the dot product of u and v is the number 27. We're going to save that because we're going to put that at the top of our fraction. Next, we're going to look at, well, what's the magnitude of our vector u? Well, we're going to go back and use our old formula. The square root of the horizontal component squared, add it to the square of the vertical component squared. So that's 4 squared plus 3 squared, which gives us the square root of 16 plus 9, or in other words, the square root of 25, or just 5 itself. Now we'll look at the magnitude of vector v using the same formula. We've got the square root of 3 squared plus 5 squared, or we can say the square root of 9 plus 25, or the square root of 34. So we're just simply going to plug in the numbers where those symbols are at in our formula, which gives us that the cosine of theta would be 27. That's the dot product of uv, all over, well, our magnitude of u was v, is 5, and our magnitude of v is the square root of 34. So that's some weird relationship between sides of the triangle, but if we remember that we can use cosine inverse to figure out what that theta is. So we're going to go back in and say, well, theta is equal to the cosine inverse of this ratio. Make sure that your calculator is in degree mode, because this will tell us what that degree measure is. And then we can say that that's 22.17 degrees. So we'll use all that information to figure out first what's the dot product, what's our magnitude of the two given vectors, and then we can go in and use cosine inverse to figure out what the angle is between those two vectors. So naturally, the next thing is, if you think, I want to do cosine. If we try to do cosine of something of, is there potential that the top of that fraction could become 0? And it turns out that this has a really special property. If your dot product is ever equal to the number 0, we're going to say that the vectors are orthogonal. Now that's kind of a strange word for you, but really what orthogonal just means is that these two vectors create a nice 90-degree angle between each other. That's all that we're saying here. And that's only true if the dot product between your two vectors are equal to 0. So we're going to look at some examples here, or just one example really. Can we determine if our vector u and v are orthogonal? Well, if they're orthogonal, then we're just going to do dot product. If we get an answer that is 0, then we know for a fact they are orthogonal, when they create 90-degree angles. So we start with our components from u and v, and we're going to multiply them up. We're going to do 2 times 6. We're going to add to that whatever negative 3 times 4 is. Well, that gives us 12 plus negative 12, and in fact, that is 0. So we can guarantee that we know that if we were to draw these two vectors out, they're going to create a 90-degree angle between each other. So we'll make a statement here. Since the dot product between our vectors u and v is 0, then they are definitely orthogonal. And what I want you to see here is I'm going to give you a visual picture of this as well. So let's see. If I draw the vector u, at our component form, it was at 2, negative 3. Here's what vector u looks like. And then if I draw my vector v at 6, 4, we can see then, visually this kind of gives a rough idea that they are creating 90-degree angles, but we can guarantee by using the dot product theorem here that they are going to create 90-degree angles in fact. So there's a short video on using the dot products to be able to find the angle between two vectors and to determine if two angles are orthogonal of each other.